Artificial Intelligence Career Roadmap. Artificial Intelligence Career Roadmap, Navigating the Future of Intelligent Systems. Introduction. Artificial intelligence, AI, is a rapidly advancing field that focuses on developing intelligent systems capable of performing tasks that traditionally required human intelligence. In this comprehensive guide, we outline a roadmap for building a successful career in AI. From acquiring foundational knowledge to specializing in specific AI domains, we cover the essential steps and skills required to excel in this exciting field. Chapter 1, Understanding Artificial Intelligence. 1.1 Introduction to AI. We begin by exploring the fundamental concepts and principles of AI, including machine learning, deep learning, natural language processing, and computer vision. Understanding the scope and potential of AI is essential for building a strong foundation. 1.2 AI Applications. We delve into real-world applications of AI across various industries, such as healthcare, finance, autonomous vehicles, robotics, and recommendation systems. This chapter highlights the wide range of opportunities available in the field of AI. Chapter 2, Acquiring Foundational Skills. 2.1 Mathematics and Statistics. A solid understanding of mathematical concepts like linear algebra, calculus, probability, and statistics is vital for grasping the underlying algorithms and models used in AI. 2.2 Programming Proficiency. Developing proficiency in programming languages like Python, R, and Java is crucial for implementing AI algorithms, manipulating data, and building intelligent systems. 2.3 Data Handling and Manipulation. Skills in data preprocessing, cleaning, and manipulation are essential for preparing data to be fed into AI models. Familiarity with libraries like NumPy, Pandas, and SQL enables efficient data handling. Chapter 3, Machine Learning and Deep Learning. 3.1 Machine Learning. We explore the foundations of machine learning, including supervised and unsupervised learning techniques, model evaluation, feature engineering, and model deployment. Gaining expertise in popular algorithms such as linear regression, support vector machines, SVM, decision trees, and random forests is crucial. 3.2 Deep Learning. In this section, we delve into neural networks, convolutional neural networks, CNNs, recurrent neural networks, RNNs, and deep learning frameworks like TensorFlow and PyTorch. Understanding deep learning architectures and techniques enables the development of sophisticated AI systems. Chapter 4, Natural Language Processing, NLP. 4.1 NLP Fundamentals. We cover the basics of NLP, including text preprocessing, tokenization, part-of-speech tagging, named entity recognition, and sentiment analysis. These skills are vital for extracting meaningful information from textual data and building AI-powered language models. 4.2 NLP Techniques. We explore advanced NLP techniques such as word embeddings, sequence-to-sequence models, and attention mechanisms. Understanding these techniques enables the development of applications like machine translation, question-answering systems, and text generation. Chapter 5, Computer Vision. 5.1 Computer Vision Fundamentals. We delve into the basics of computer vision, including image preprocessing, feature extraction, object detection, image segmentation, and image classification. These skills are essential for developing AI systems that can understand and interpret visual information. 5.2 Deep Learning for Computer Vision. we explore deep learning approaches in computer vision, including convolutional neural networks, CNNs, object detection algorithms, e.g., YOLO, SSD, and image generation models, e.g., GANs. Mastery of these techniques enables the development of AI-powered vision applications such as image recognition, object tracking, and autonomous driving. Chapter 6: Reinforcement Learning. 6.1 Reinforcement Learning Basics. We introduce the concepts of reinforcement learning, including Markov decision processes, policy evaluation, value iteration, and Q-learning. Understanding these fundamentals is crucial for developing AI systems that can learn from interactions with an environment and make optimal decisions. Advanced Reinforcement Learning. We delve into advanced techniques such as deep reinforcement learning, model-based reinforcement learning, and exploration-exploitation strategies. Mastery of these techniques enables the development of AI agents that can achieve superhuman performance in complex tasks. Chapter 7: AI Ethics and Responsible AI. 7.1 Ethical Considerations. We explore the ethical implications of AI, including fairness, transparency, accountability, and privacy. Understanding ethical considerations is crucial for developing AI systems that align with societal values and mitigate potential biases and harms. Seven point two Responsible AI Practices. We discuss guidelines and frameworks for responsible AI development, including data governance, algorithmic transparency, and the integration of ethical principles into the design and deployment of AI systems. Chapter 8: Specializations in AI. 8.1 Natural Language Processing, NLP, Specialist. We explore advanced topics in NLP, such as language modeling, machine translation, sentiment analysis, and chatbot development. Gaining expertise in NLP allows you to tackle complex language-related challenges and build cutting-edge language models. 8.2 Computer Vision Specialist. We delve into advanced computer vision techniques, including image segmentation, object recognition, image synthesis, and video analysis. Specializing in computer vision opens up opportunities to work on diverse applications such as autonomous vehicles, surveillance systems, and medical imaging. Robotics and Autonomous Systems. We cover the integration of AI with robotics, including perception, motion planning, control systems, and reinforcement learning for robotics. Developing expertise in robotics and autonomous systems allows you to contribute to the advancement of intelligent machines and automation. Chapter 9: Industry Applications. 9.1 Healthcare. We explore how AI is transforming healthcare through applications such as disease diagnosis, medical imaging analysis, personalized medicine, and drug discovery. 9.2 Finance. We discuss AI applications in finance, including fraud detection, algorithmic trading, credit risk assessment, and customer behavior analysis. 9.3 E-commerce and recommendation systems. We delve into the use of AI in e-commerce, including personalized recommendations, demand forecasting, and customer segmentation. 9.4 Autonomous Vehicles. We explore the intersection of AI and autonomous vehicles, covering perception, decision-making, and control systems for self-driving cars. Chapter 10: Continuous Learning and Professional Development. 10.1 Staying Updated. We emphasize the importance of continuous learning and staying updated with the latest advancements in AI through research papers, conferences, online courses, and participation in AI communities. 10.2 Building a Portfolio. we discuss the significance of building a strong portfolio of AI projects to showcase your skills and expertise to potential employers. 10.3 Networking and Collaboration. We highlight the benefits of networking with AI professionals, participating in collaborative projects, and leveraging online platforms to foster professional connections. Conclusion. Embarking on a career in artificial intelligence offers exciting opportunities to shape the future of intelligent systems. By following this roadmap, acquiring the necessary skills, specializing in specific AI domains, and staying abreast of advancements, you can navigate the ever-evolving landscape of AI and contribute to groundbreaking innovations. Remember, this roadmap provides a general framework, and individual journeys may vary based on personal interests, industry preferences, and emerging AI trends. Thanks for watching.